So hello and welcome. So this session presents examples on the wind load calculations as well as introduction on the codes or relevant codes with respect to the wind load calculations. Okay, so as we all know that the wind has significant effect on the structure, especially during typhoons or a heavy wind blow. It will have a wind load, or especially that a structure composes of a surface. A surface, as we all know, is a catchment for the wind. So there are several factors that affects the wind pressure that will be applied to the structure. So what are those factors? So we have here factors affecting wind pressure. So number one, it is dependent on the exposure of the structure. And then we have certain increase in the wind pressure because of the hills and escarpments. Okay? So kung yan, magkakaroon yan ng change in speed, or perhaps that is increasing in the wind pressure depending on the hills surrounding the structure. And for number 3, the wind direction. So there are factors that considers the wind directions. All of these 3 will be incorporated on the formula of mean velocity pressure. So what is mean velocity pressure? That is QZ. So the mean velocity pressure, or abbreviated as MVP. Okay, so if you wanted to remember that, just abbreviate it as MVP. That is actually QZ. It contains all of these 3 factors. So perhaps you can write that in terms of English units. And SI units. So for QZ in English units, we have 0.00256 kz times kzt and kd times v squared. And for SI unit, the mean velocity pressure is 0.613 kz times kzt times kd times v squared. So isa-isay natin to. Ano ba yung kz dito? So kz is both based on the exposure of the structure. There are certain factors present in the table. Nag-iiba-iba yung factor ng kz, especially if the height is increasing. If the height is increasing, of course, masasabi natin, mas nagiging exposed yung ating building. Pero kung mababa yan, less exposure yung building in terms of mean velocity pressure. Okay, so you can find that in the tables here. I think that is a table 1-5, which accounts for that one. Okay, so here it is. So as we can see, there are certain ranges of Z. What is Z? Z is measured from the ground up to the height concerned. or height of your structure. Okay? So Z has a range of values in terms of feet and meters. So as we can see, the first 15 feet or 0 to 4.6 meters has a KZ value of 0.85, and then onwards it will be increasing as the height increases. Okay? Sabi nga natin, kapag height nag-i-increase, it is more vulnerable to wind exposure. So it can be found in table 1-5. Okay? So ngayon, yung KZT is the increase in wind pressure depending on the effect of hills and encampments surrounding your building. May effect yan. If your building is assumed to be a flat terrain, then KZT is set to be equal to 1. Okay? Kapag flat surface, or so flat terrain, I should say, flat ground or flat terrain, we will set our KZT is equal to 1.0. However, if we have escarpments and hills present to it, there is a tedious evaluation of coefficient of KZT. Okay, so KZT here will have this equation. There are three factors, K1, K2, and K3 present in the table, and then plus 1 that is squared. So this is the diagram that we should consider. If we have here LH is actually a horizontal distance. If we have a sloping ground here, just get the half of it, that is LH. Similarly, if we have a slope on both ends of a hill, okay, so this is a 2D ridge or a 3D axis symmetrical hill, meaning yung both sides is symmetrical, then we will be having a common value for LH. Okay, so ito yung slope natin. I-half mo yan, that is the LH. It is measured from the top. Okay, so the height, just measure the ground from the ground up to the top of the hill, that is H, and then just divide that H over 2. Yun, dun na magagaling yung reference ng LH. Okay, so para saan ito yung mga LH saka H? So kukumputin natin yan. Nang sa ganon, we can evaluate the factors on this table. Sorry. So on this table. Yan. Yung K1 multiplier, it's dependent on the value of H all over LH. X is along the X direction. Z is along the Z direction. Kasi nga ito, it entails 3D or 2D escarpment or considerations. Okay, so these are the values. We'll just have to get values from this table and then substitute on the equation of KZ to come up with the coefficient. Okay, now sabi nga natin, kapag flat ground, KZT is just equivalent to 1.0. So that's it. So next, the mean velocity pressure is also affected by the wind direction. So it depends on the wind direction. So if it is combined with the other loading, we are going to use a certain table for that. KD. So this is the table consisting of values of wind directionality. We have table 207A.6-1. We're just gonna use this structure type buildings with the MWFRS for components and cladding, arch roof, chimneys, tanks, and similar structures, solid freestanding walls, etc. So those are the factors. However, if your structure or your analysis does not combine with any other loading, so if we are just concerned with the wind loading, then we will set that KD is equal to 1 if we are just concerned with wind load alone. Okay? So hindi na natin i-combine yan sa ibang load combination like earthquake load or live load or dead load. Then KD is equal to 1. Otherwise, we will go back to that table. Okay, so SI units as well has a values for that. Mean velocity pressure, that is 0.613 kz, kzt, kd times v squared. Now, what is this v squared? So v here is the velocity at a 3-second gas effect measured from up to 10 meters, from the ground to up to 10 meters, or that is equivalent to 33 feet. So yung value ng v is dependent on the wind map. So iba-iba yung wind map in every country. Iba yung velocity natin dito sa Kalinga at iba yung velocity natin dun sa NCR or in Manila. So this can be found on wind map present in National Structural Code of the Philippines. So in other countries, meron din silang wind map for that. Okay? So itong mean velocity pressure shall now be the basis for computing the design pressure P. So ito yung design pressure P. So the design pressure P is expressed by this equation. Q times GCPI minus copyain mo lang, GCP yan. Q GCP minus, and copyain mo yan. Lagyan mo lang ng I doon. Tapos ito, lagyan mo ng H. Okay? So, what is this formula all about? By the way, kung titignan natin to, ang unit dito is unit for pressure, no? Ano ba yung unit for pressure ng English system? That is English system. Pounds per square foot. Ito naman, Newton per square meter. So, Pascal and PSF. So, this will be expounded to the design pressure P. So, yung design pressure P, ito na yung pressure na mailalagay doon sa surface ng building, whether it is wall or roofing. So, yun lang naman. Yung mga surface is yung wall at roofing and any cladding. Okay? So, those are the subjects of wind pressure. Kapag hindi surface yan, very minimal lang yung effect ng wind. So, this time, the design pressure is coming from the value of the QZ here that is computed. Bakit nagtago dito yung Q? Asan yung QZ dito, class? Yung Q at yung QH. Ano bang ibig sabihin yan? Itong QH dito is computed based on the mean height. Ano ba yung mean height? H. Okay. Yung mean height H, if we have here a structure, okay, yung mean height H, mula dito sa ground, from the ground up to the half of this king post, ito yung tinatawag na mean height denoted by H. Okay? So, yung mean height H, it covers also the diagonal member, also the slope member here. Ngayon, ano naman yung Q dito? Yung Q dito, based on vertical distance Z on wall. So, nasan yun? So, the highest point, the Z maximum is the highest point up to the roof level. So, that is Z max. So, before we have this Z max, may mga values ng mga Z dito. Okay? So, depende kung anong nasa range ng table. Kung titignan natin yung range ng table, yung QZ, no? Where's the table? Table 1-5. So, here it is, table 1-5. There are certain ranges for the first 15 feet, 20 feet, 25, 30, 40, 50. Of course, yung pinakamalapit ang titignan natin dyan sa pinaka-Z maximum. For example, ang Z maximum mo or the roof level is on 25 or 26 feet. So, yung values ng mga Z mo, okay, kung 26 feet, yung Z mo is 0 to 15, 20, and 25. So, ngayon, nag-iiba-iba yung values ng KZ. Kapag nag-iba yung values ng KZ, of course, mag-iiba rin yung value ng QZ. Okay, that is the Q that is defined here. Ito yun. Ito yung Q. Actually, Q is QZ or it is a changing value. Sabi nga natin ito, exposure yung KZ, exposure factor. Pag tumataas din yung effect ng wind. That is why, kung titignan natin, if this is the structure, okay, so this is the structure, Z is, or KZ is increasing as Z increases up to the Z maximum. Okay? Kaya yung itsura ng pressure niya is ganito. Mababa pa lang siya dito hanggang tumaas doon. Sabi nga niya, meron siyang first 0 to 15. Ito, 20 na yan. And then, meron siyang value for 30, etc. So, surutin na dito eh. Okay? Susundan niya yan. Yung pag-increase ng KZ dito. So, as we can see in the formula, nasan ba yung KZ sa formula? Nandito siya. It is a part of the QZ. Ngayon, pag nag-increase yung KZ, of course, the mean velocity pressure will also increase. That is why, dito sa design pressure, this is a changing value. Ngayon, yung QH, hindi na nag-change yung value niyan. Bakit? Kasi isa lang naman yung mean height. Okay? Unlike Q, depending on the range or the height of the structure, you must have to follow the range defined in table 1-5. Okay? So, next. How about G here? Yung G dito is the gas effect factor. It is also present in the table. And GCPI is internal pressure coefficient. Why do we need to have this? Because it depends. Of course, kung fully enclosed yung building mo or your structure, it will have more vulnerability to the effect of the wind. Ngayon, kapag open yan, may internal pressure yan sa loob as well as G or gas effect factor. So, where is that table involving that one? So, the table for the GCPI, ito. Sorry. So GCPI, perhaps we can have this presentation. Ito, GCPI, internal pressure coefficient. For a fully enclosed building, it could be plus or minus 0.18. Why plus or minus? Because your effect could be a suction pressure, suction, hinihigop, or a positive pressure, tinutulak. Okay? Pwedeng higop or pwedeng tulak yung pressure. So, it depends. Kapag open yan, 0, 0. Wala. GCPI has no 0. Has no factor. Kapag 0 yan, 0 na yung GCPI mo. Partially enclosed, plus or minus 0.55. Totally enclosed, plus or minus 0.18. So, what else? So, gas effect factor. For a rigid structure, we have 0.85. Kapag rigid, 0.85. But in our code, there are more detailed calculation of the gas effect factor. No? So, gas effect factor, just set it to be 0.85 if we have a rigid structure. Because kung minsan di naman maganda ang rigid structure. Kasi nga parang ano yan eh. It is compared to a bamboo and a mango tree. Yung bamboo, sasayaw-sayaw lang yan during a strong wind. But in the rigid structure, kapag rigid, matibay, anong mangyayari? Like manga or mango tree, it will collapse because yun nga wala siyang swaying effect. Okay, so going back to this, we are in this equation, so we are done. So P here is equal to this minus that. Kapag open, magiging 0 na yan. So ang effect, as an effect, we have Q, G, CP. So, ano ba yung CP dito? So, this is the wind pressure coefficient. So, it depends whether you are concerned with the wall or the roofing. So let me have this simple illustration. Ang concern lang naman natin is yung wall ba? May pressure dyan. Okay? There is a pressure there. May pressure din dyan. Sa kabila, meron din siyang pressure. Okay? At dito. So let me have a dividing line here. Okay? So ang tawag dito sa left side, kung dito nanggaling yung wind. Okay? So if the direction of the wind is on that side, therefore, ito ang tinatawag na windward. Okay? So kapag nasa kabila yung wind, ito yung tinatawag na leeward. Kaya pag sinabing windward wall, ito yun, windward wall. Pag sinabing windward roof, ito yun. Kapag leeward roof, ito yun. And if we have a windward or leeward wall, ito yun. So those are defined in the table also involving the internal or pressure coefficient CP. Okay? Ito. So this table. So this is the table. There are values for CP on various conditions. Ano ba yung ini-investigate natin dito? L over B. What is L? Ayan, L yung harap na dimension at yung B is yun yung dimension that is perpendicular to the wind direction. Okay? So sa L over B, kapag all values, whatever the value of L over B, kapag windward wall ang pinag-uusapan, no problem, all values has a CP of 0.8. And this is used with QZ. Okay? Ano ba yung QZ? Z is a changing value. Okay? So it must be used with QZ. And then leeward wall, dito sa kabila, this is leeward. Kukumputin natin yung L over B. Kapag 0 to 1 yan, within this range, that is negative 0.5. Kapag within the range of 2, that is negative 0.3. Kapag greater than or equal to 4, that is negative 0.2. So, as we can see here, may mga gap yan, di ba? Tatanungin nyo, paano sir pag 1.5? Wala naman dito sa table. We will use interpolation to obtain CP. Halimbawa, 3 yan. Wala naman dito sa table. Dito ba? 0.2 ba yun or 0.3? It is somewhere in between. That is why we can use the interpolation method in order to come up with the CP values. For the sidewall, ito naman yung sidewall. Harap at likod. All values will have negative 0.7 as the value for CP. Okay? So, ito para sa wall. Okay? At itong table B is para sa roof. So, ang investigate naman natin dito, H all over L. So, H is the mean height divided by the length. Whatever the value is, we have a corresponding angle. Ito, isang angle lang ang kinonsider, but may mga table po yan. Ayan o. So, different values, different angles, windward and leeward. This is a table for roof pressure coefficient CP to be used with QH. Okay, so let us consider this first problem. So this problem came from just the same. We have the book of Hibbeler as a reference. So 1-15, wind blows on the side of a fully enclosed hospital located on open flat terrain in Arizona. Determine the external pressure acting over the windward wall, which has a height of 30 feet, and the roof here is flat. So from the wind map of Arizona, it is having a velocity or wind velocity of 100 miles per hour. So this is an English unit. So we will be dealing with the English formula. Okay. So the formula for mean velocity pressure, QZ, is equal to 0.00256 kz kzt times kd times v squared. Okay, so as we can see here, we have a roofing that is flat. Therefore, if we are going to illustrate the building structure, we have here as the building structure, the flat is this roofing. Therefore, the mean height is 30 feet. So there is no additional height here for the mean height. So the mean height here is 30 feet. This is the mean height h. And then kzt, or from this, we are going to have a calculation for kz for a height lesser than 30 feet based on the table 1-5. So sa table 1-5, we are going to consider yung mga height na mas mababa sa 30, and that will be our range in computation of the windward wall. We have a changing value for that. Meron tayong first 15 feet, and then 20, 25, until the mean height of h. Okay, so Z max here is actually equal to the mean height h, 30. Okay, so by that, kz here is a changing value. Remember that. Okay, so kzt here is the increase in speed depending on the escarpments and hills. However, in this problem, it mentioned that the structure is within an open flat terrain in Arizona. So meaning, if we have a flat terrain, then we can set our kzt be equal to 1.0. So next, how about the value of kd? So kd here, we are just concerned with the wind load. Although this is a directional factor, we will just consider here kd is equal to 1 because wind load here is not combined with any other loading as mentioned in the as the problem is silent about it, but we are just concerned with the wind pressure acting externally. Okay, so we are going now to compute for QZ. QZ is equal to 0.00256. So we are going to leave KZ. Okay. We'll write KZ as it is, because KZ here will be a changing value by and by. And then KZT is 1. Okay. KD is 1. And then we have here 100 squared. So from that, QZ will now be equal to 25.6 times the value of kz. Okay, so perhaps we can put it in a matrix form, because as we can see, qz here is a changing value. Okay, so we're going to have a range for z. Okay, meron tayong z range dito. Ano ba yung mga range? First, 15 feet. Okay, sunod is 20 feet. Sunod is 25 until 30 feet. Okay, so there will be a corresponding kz for each of these range. First 15, we have 0.85, then 90, 0.94 until 0.98, and then there will be a corresponding QZ here, 25.6 times 0.85, 25.6 times 0.9. There will be values here. Okay, so here are the values: 21.76 for first 15 feet, 20 feet is 23.04. For the 25, we have 24.06. And for the mean height, perhaps we can highlight this one. Pag mean height na yan, ito na yung value ng, ito na po yung value ng QH. So yung QH, it is already fixed, or the highest value on QZ. Okay, ito yung QH, ito yung QZ. So moving on, we are now ready to determine the design pressure on the windward wall. Ito yung windward, this one, this side on the left portion. So the windward have different values. Okay, because again, CP is changing, as we can see here on the table. Or sorry, windward wall. If we are concerned with the windward wall, titignan natin dito, lahat po ng values ng L over B is equal to 0.8. We're gonna use that with QZ. Okay? So, lahat ng values ng L over B will be equal to 0.8 for the windward wall. So, no need to calculate for our L over B. Okay, so that is the value for CP, 0.8. Okay? So, now, we will have the pressure computation. Okay, we'll just erase this for a while. Okay, for the pressure calculation, we will have the formula P is equal to P is equal to Q times GCP minus Q times GCP, lagyan mo lang ng I doon, lagyan mo ng H doon. Okay? So, we'll start with the first 15. The pressure for the first 15 height is equal to, what is QZ here? QZ here is 21.76. Okay, what is its G? Gas effect factor. So for a total, what is that? Gas effect factor for a rigid structure that is equal to 0.85. So this is a rigid structure, assumed to be rigid structure. So gas effect factor is equivalent 0.85. And then for the CP, for all values, we have said that is equivalent to 0.8. Eh yung QH, yan, fix yan, 25.09. Okay? So this is a totally enclosed structure. Okay? Fully enclosed hospital. So if it is fully enclosed, your GCPI would be equal to plus or minus 0.18. Okay? So let us compute for the values. Okay, we have P 0 to 15, 14.79 plus or minus 4.52. So we have an upper limit and a lower limit here because if we employ plus here, this will combine 19.3. And if we employ negative here, we have 10.27 PSF. So all positive. All positive means patulak yan. Okay? So similarly for the other height, we are going to have this one. So at 20, we have next to 21.76 is 23.04. Okay? 23.04. The same factor here. 0.8 and then minus 25.09 plus or minus 0.18. So we have here the same 4.52 at this side, and then we compute for that one. So we have here 20.19 PSF or 11.14 PSF for pressure at height 20 feet. So next to that is pressure at 25 feet. Okay, so pressure at 25 feet. So P25 is equal to, so instead of 23.04, we're going to have this 24.06 times 0.85 times 0.8 minus, okay, we're just gonna copy that, 0.9 plus or minus 0.18. So therefore, P at 25 height is equivalent to, so we have 16.36 plus or minus 4.52. We have 25 pressure is equal to 20.88 PSF or 11.84 PSF. Okay, so that is up to 30. We had actually compute for QH. So what will be the pressure at 30? So P30, this time we're gonna use QH 25.09, 0.85 by 0.8 minus 25.09 plus minus 0.18. Okay. So, ito plus minus na yan. This one, 4.52. And then, 25.09 times 0.85 times 0.8 is 17.06. So, this is P30. So, at last, we have here P30, 21.58 as the upper limit, or for the lower limit, we have 12.54 PSF. So for 30, the pressure is this one for the windward wall. For 25 height, this is the windward wall pressure. For the 20 feet height, this is the windward windward pressure, and for the first 15, this is the windward pressure. Okay, so those are the answers for the problem, for the first problem on this. Okay.